Hi students, today we are going to discuss about reaction intermediates. The first one is carbocation. Okay, so what is carbocation? Positively charged carbon species is called carbocation. Right, positively charged carbon. Right, and there are different types of carbocations are there. That is saturated carbocation, that is alkyl carbocation, then unsaturated carbocations, that is alkenes, alkynyl carbocation, alkynes, alkynyl carbocation, then benzyl carbocation, allyl carbocation, right? Then tropylium carbocation, cyclopropyl carbocation, cyclopropyl methyl carbocation, right? There are different types of carbocations. So first of all, we discuss about carbocation, different structural aspects. This are right. So here, for example, take it simplest carbocation, that is a methyl carbocation. Here, the carbon is bonded with three hydrogen atoms, right? Yeah, and it having one positive charge. So here, total number of covalent bonds present on the carbon atom is 3. Then total number of electrons present on a carbon, that is one covalent bond is 2 electrons, 3 covalent bonds, that is 6 electrons, right? So stability is due to presence of 8 electrons, so that's why we have only 6 electrons. It needed 2 more electrons to get stability, 6 plus 2 8, so that's why it is unstable. So it is unstable, it is not stable, right? So being unstable, it have to accept a pair of electrons to get stability. It is an electron pair acceptor. Electron pair acceptors are called, according to Lewis acid base theory, electron pair acceptors are called Lewis acids. Lewis acids, right? So being an electron deficient, it have to gain 2 electrons from others. So that's why it is actively participate in chemical reaction to take 2 electrons from others and to involve in bond formation. So that's why it is a highly reactive species. Highly reactive species, right? And here the carbon atom having 3 sigma bonds are present, okay, and one positive charge. So that's why the carbon undergoes what type of hybridization? sp2 hybridization, okay. So here 3 sigma bonds and one positive charge is there. So that's why the carbon undergoes sp2 hybridization, sp2 hybridized carbon, okay. Then what is the geometrical shape of the carbocation is? sp2 means planar geometry, trigonal planar geometry. It have planar geometry, right? Okay, ma. So this is about the general information about carbocation. And here, how many electrons do we have? 6 electrons are there. So that's why all are paired electrons. So that is, there is no unpaired electrons. That's why it is diamagnetic in nature. Carbocation is a diamagnetic nature because there is no unpaired electron. No unpaired electron, so that it is diamagnetic in nature. Each and every point is very important for objective examination, my dear students. Yeah. Now, let us do now types of carbocations. Yeah. Types of carbocations. So from saturated carbocations, there is alkyl carbocation. For example, R, it is bonding with some Y. So Y is more electronegative. So that's why these 2 electrons taken by Y and it is removed as Y minus. Then alkyl group gets less electron density. So that's why it gets positive charge. It is a alkyl carbocation. If it is a methyl, so we take CH3Cl. Okay. So then it takes up 2 electrons. It is removed as Cl minus. Then we get CH3 plus. It is methyl carbocation, right? Or if you take here, there is C2H5Br, okay, and bromine takes up 2 electrons, it is removed as Br minus, and you get ethyl carbocation, okay. ethyl carbocation. Then they get, for example, 3 carbons are there, okay, and here some Y atom is there, it is more electronegative, it takes up 2 electrons. Then you will get it is Y minus, then you will get it is a 3 carbons, this carbon carrying positive charge, a linear, so that's why it is a N propyl carbocation. Then if it may be like this, here Y is bonded to this one, this middle carbon, and it is moves as Y minus, it takes up 2 electrons. Then you will get, yeah, that is this carbon gets positive charge, right, this carbon, middle carbon. Now this is CH3 taken twice group is called isopropyl group, then it is called isopropyl carbocation, right, okay. So there is alkyl carbocation, then this is methyl carbocation, and this is ethyl carbocation, and this is N-propyl carbocation, and this is isopropyl carbocation, right? You're following, right? Yeah. Okay. Then take for example here, this is tertiary group here, and here Y is there. So Y is bonded to this carbon, it is bonded to 3 other carbons, it is a tertiary carbon. So it is removes as, this takes up 2 electrons, it is removes as Y minus. Then this carbon, that middle carbon gets positive charge, yeah. So then it gets positive charge, it is a tertiary butyl carbocation, tertiary butyl carbocation, right? Tertiary butyl carbocation, okay na? Right. Next one, take it here, it is a allyl carbocation. So here 3 carbons are there, and here double bond, okay, and here Y atom is present, right. Then we will get it here, this takes up 2 electrons, it is Y minus, and then you will get this is carbon carrying positive charge, it is a allyl carbocation, right. So in this case, in all this one, the carbon atom undergoes what type of hybridization? sp2 hybridized carbon here, okay. In all these cases, in all these things, the carbon atom undergoes sp2 hybridization. This is sp2 hybridized carbon, sp2 hybridized carbon. Is it clear? Okay, got it? Copy it, take a screenshot. So some more types are there, we'll do. Yeah. Right. Can I erase it now? Yeah. And here, next unsaturated carbocations. Unsaturated carbocations. For example, take it alkenes. Okay, from alkenes, a carbon-carbon double bond. Okay. And here CH2, there is groups are there, and here CH, okay. So this is what represents CH2, double bond, CH, positive charge, right. Now, this carbon, it is called, 2 carbons are there, it is ethynyl carbocation, and here the carbon undergoes what type of hybridization? General students are committing a mistake. It is sp hybridized carbon, not sp2, it is undergoes sp hybridization. Take care. Why? Because here, so this carbon is just represent this one, the structural formula. Here carbon, and here carbon, and here hydrogen is there, here 2 hydrogens are there, and between these once a pi bond is present, right? This pi bond. This pi bond is formed by lateral overlapping of atomic orbitals, right? Okay, and then here, so this is 1 sigma and 1 sigma, 2 sigma bonds are there. That's why this one undergoes, because of presence of 2 sigma bonds, it undergoes sp hybridization. Got it? Yeah. So this is lateral overlapping, we'll get that is a pi bond, right? Okay. Next one. So this is formed by the overlapping of, sigma bonds formed by, that is hybrid orbitals. Hybrid orbitals never form pi bonds. So this pi bond is formed by only, that is a pure paired atomic orbitals, they are overlapped, so we will get the pi bond. So that's why here, so this is a hybrid orbital, this is hybrid orbital, only 2 sigma bonds are there. That's why the carbon undergoes sp hybridization. Is it clear? Very nice. Okay. More. Come on, next one. Then we get here alkynes more. Alkynes. So in case of alkynes, we get here carbon triple bond is there here, and here hydrogen atom, and it gets positive charge. So here also what the carbon undergoes here. So this is this is sigma bond, 1 sigma bond, and 2 pi bonds are present, right? Okay. So these pi bonds are formed by lateral overlapping of atomic orbitals. So this is you can represent like this. It is a sigma bond, and this is a sigma bond, right? So this is sigma bond. It is sp hybridization means, that is here this carbon is sp hybrid orbital. This is sp hybrid orbital. So this is a sp hybrid orbital, right? And these 2 pi bonds are not formed by hybrid orbitals. So that's why this is formed by that is pure atomic orbitals. This is one pi bond, and the other one you have to represent like this, and okay, another one you have to represent like this. This is okay, yeah. So this is another pi bond. So then you get automatically you get this carbon undergoes sp hybridization, sp carbon. Okay, got it? Yeah. Next one we get here. So this ethynyl carbocation. This is, and this one is called ethynyl carbocation. Ethynyl carbocation, right? And this one is ethynyl. It is also called as vinyl carbocation. Vinyl carbocation, right? And this is ethynyl carbocation. Correct. This ethynyl, E, and this is I. Okay. That is. Next one. Can you get here a benzyl carbocation? Benzyl carbocation. This is here toluene, that is right, toluene, benzyl carbocation. This is CH2, and here positive charge is there. So that's why here this carbon undergoes sp2 hybridization, right? Then look at here. This is a here the carbon, that is a cyclopropenyl carbocation. So this is called cyclopropenyl carbocation. Yeah. Next, this is what? Benzyl carbocation. Yeah. Then this one you can represent for our convenience like this. Yeah. So here double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond, right? Yeah. Now this is called what? So this is troponium cation, right? Troponium carbocation, right? And then just represent like this. This is carbon, here bond, and here methyl group is present, that is CH2 plus. So this is called cyclopropyl methyl carbocation. Now to represent this is called what? Cyclopropyl. Okay, cyclopropyl. We just represent here cyclopropyl methyl carbocation. Okay. This CPM carbocation. CPM means not CPM party. That is cyclopropyl methyl carbocation. Okay. Is it clear? There are different types of carbocations. Okay, my dear students. Fine. Yeah. So this is about what is introduction and important properties, characteristics, and then different types of carbocations. That is methyl, ethyl, N-propyl, isopropyl, tertiary methyl, and then unsaturated vinyl carbocation, ethynyl and ethynyl, and then benzyl carbocation, then cyclopropyl. This is called what? This is cyclopropyl. This is cyclopropyl carbocation, cyclopropyl or cyclopropionate, okay, and then this stroponium carbocation, and then CPM, cyclopropyl methyl carbocation. Is it fine now? Okay, I think you got it, all these concepts. Okay, like it, subscribe it and share to your friends now. Thanks for watching my video. Thank